So for this question, the best way to explain it is that the magnitude of the acceleration is going down because of that force. But even though that magnitude of the force is decreasing, so it's going downwards, that acceleration is still being pushed over to the right, because it's not saying at all that that force is stopping whatever motion is coming in. It's just, he literally says here, the net force on the object is directed to the right, but the magnitude of the force is decreasing. So therefore the closest answer is, the best one would be that will continue to move to the right with the speed decreasing over time. Now for this question, we have to put in this formula, which is the work is the change in the kinetic energy. So that formula is here described as 1/2 the mass times the velocity final squared, or 1/2 of the velocity initial squared. And we can really just go ahead and plug in the numbers, which the numbers are going to be, what we want to do is remove the possibility of that negative. So we have that W plus 1/2 of mv initial squared equals 1/2 of mv final. So we multiply that by 2 to remove those half signs. And then what we do is we go ahead and just plug in whatever values we're given in this formula, which we know is 4.5 4 times 10 to the 5th joules of work, and we plug in that mass, which is 1,167 kilograms, minus that initial value that we're given as well. I kind of simplified it, but it didn't really work out, so I'm just going to go ahead and do it like this. And we continue to simplify this problem. And when we finish and we basically plug in all these numbers and we solve for VF, which is what it's looking for, that final velocity, after we divide all these numbers and simplify it with the square and also such, the number we get is 28.02, which is closest to 28 meters per second.